So a distance x of a parabole from a fixed point is given by the position x equals a cos wt plus e, where a, w and e are constants. Show that the motion of the parabole is simple harmonic motion. Okay, so what we need to do is differentiate twice. First derivative, what happens is the cos omega t plus e turns into minus sine omega t plus e. This minus sine is being multiplied by the a that's in front. Then we differentiate the angle, which is omega. So we're going to get minus a omega sine wt plus e. Second derivative then for acceleration, which is d2x dt squared. Like last time, the two of these go directly down, and then we differentiate this into cos wt plus e. Then you got to differentiate the angle at the end, which is going to be just w. And then we're going to get minus aw squared cos wt plus e, close brackets. Now, what you know about this here, the a and the cos wt plus e, you know that that's x, so it's minus omega squared x. So your acceleration is minus omega squared x. Therefore, it's simple harmonic motion about x equals 0. Okay. Next part. If the period of motion is 11 seconds, find the maximum speed of the parabole, correct 2 decimal places. Now, there's a trick in this. The trick is that the maximum speed isn't in your notes. Okay, so what you would get is v squared equals w. Sorry, v squared equals w squared into a squared minus x squared. Now there's one thing you need to remember about simple harmonic motion. When your particle is at the middle, you're at your maximum velocity. So right now it's turning around and then it hits the middle of the motion at its maximum speed, comes back, slows down, then comes back at the same speed. So what happens is x equals 0. So you have v squared equals w squared a squared, v equals w a. So you actually have to go about finding out what is your amplitude, and once you've found, you have to find out what your amplitude and your omega constant is. Okay, so what you know is the period is 11, which means 2 pi over w equals 11, and this means that w equals 2 pi all over 11. So you found out what w is, now you're struggling to find out what a is. Okay, so x equals a cos wt plus, wt plus e, in the brackets there, okay, so cos wt plus e, close bracket. Now, what happens is the velocity is the first derivative, and we know that parabole leaving simple harmonic motion starts from a point, starts at t equals 0, x equals 5, and v equals 1. That's a lot of information for one part. We got phi, x and t. So what do we have? Phi is 1. Okay, so you could actually use, so you have phi equals 1, is it? And x equals 5. And I know that w equals 2 pi over 11. So I think we could actually use this formula again as opposed to whatever way I did it there. We could have used phi squared equals, what is it, a squared? Sorry, omega squared. A squared minus x squared. So what I could have got here was 1 equals 4 pi squared over 121. A squared is going to be a squared we don't know, and x squared is 25. I think I have enough there to solve that. 121 equals 4 pi squared a squared minus 25 pi squared. And then, so 121 plus 25 pi squared divided by 4 pi squared. Now let's see what happens here. Complete different way down it. 121 plus 25 pi squared divided by 4 pi squared. 9.31. Square root the answer. Is that right?
You need it's 100 pi squared.
Okay, so it's 100 pi squared because it's 4 times 25 is 100 pi squared, and that there is going to be 100 pi squared here. Okay, so let's try this again. 121 plus 100 pi squared divided by 4 pi squared. Now you get 28.06. Square root the answer. 5.29 rounds off to 5.3. Amplitude is 5.3 centimeters. The maximum velocity, phi equals omega a, and phi therefore is going to be 5.3 times omega. What's omega? 2 pi over 11. Put that into the calculator and we find that phi equals 3.03 centimeters per second. Finally, the table moves in a horizontal plane with simple harmonic motion. The table completes n oscillations per minute. Now remember this one being quite a tricky question. Okay, so we have R going up, mg going down, and mu r being the friction. So it's mu r, and this is r, this is mg. Table moves in a horizontal plane with simple harmonic motion. The table completes n oscillations per minute. Okay. Frequency equals n divided by 60 per second. Because we don't deal with minutes, we deal with seconds. Okay, so you divide whatever n is by 60. Okay. The period of a motion is going to be technically period is 1 over frequency. Okay, and 1 over frequency is the same thing as 1 divided by, sorry, I mixed this up. What I meant to get is frequency is 1 over the period, and 1 over the period is 1 over 2 pi over omega, and that will give me omega over 2 pi. Okay, so omega over 2 pi has to equal n over 60, and that means that omega equals n pi over 30. Now, if you imagine what's going on, it's something like this, guys. Okay, here's how I'm visualizing this. There's a table, okay, and on this table it's spinning around. Okay, and then there's the block that's on it. Okay, and the block is, which way is the block sliding, lads? The block is sliding out to the radius, so that's where its friction is going. It's sliding out of the plane of the disc. Okay, so force equals mass times r times omega squared. Now, omega squared, okay? So, the force is going to be the friction acting to the right, and centripetal force acting to the left, balancing it in play. So mu r equals m r omega squared. Okay, and this is going to be u mg. Mu mg equals m r w squared. The m's will cancel. Then we're ending up with mu g ends up to be r omega squared, and we know omega squared is pi n over 30 squared. And now we know that this is going to be what's it, r times pi squared n squared all over 900 equals mu g. And then finally r equals 900 mu g all over pi squared n squared. Okay, and that's your answer for that. The whole point of this is to understand that the radius of its motion is the amplitude away from the center, and therefore r radius is equal to the amplitude. Okay.